Okay, Mr. Derry here. We're going to put some toolpaths on our airfoil. Last time we kind of had a rough day. You may or may not have added this feature here, which is going to help out with the creation of the toolpath. So if you haven't done that, see me about adding that. It's not difficult. We just made this additional box here and did a mid-plane extrusion. But see me about that if you don't have that feature added yet. Okay, the other mistake we made is our coordinate system is off, so we're going to create a new one. Very important that we get the correct coordinate system so that the machine knows where 0 is. So we're going to right click, delete that coordinate system, and start with the new one. Okay, to get a coordinate system you need to hit the Features tab, come under Reference Geometry and select Coordinate System. We're going to select the midpoint of this line right here. You're going to get a little orange dot showing up if you select it correctly. And we want to understand this triad so that we make sure that positive X is pointing in the right direction. Currently X is the red, X is the red arrow and it's pointing in the wrong direction. So I'm going to flip that so that my X is pointing to the right, which would be positive X values. I'm going to click into Y, and for my Y axis, I'm going to select this edge right here, and I want that Y axis, whoops, I had X still selected. Let me clear that selection and start again. So for my X axis, we're going to go here. I want to flip its direction. For my Y axis, I want to go here, which is the green. And if yours is pointing in the wrong direction, you can flip it. Ultimately, the triangle or the triad needs to have the blue pointing up, the red to the right, and the green pointing off the leading edge of the wing. If you've got that selected, you can hit OK. Mine says coordinate system 3, yours might say 2, doesn't really matter. As long as the Z is up, the Y is forward, and the X is to the right, you are in good shape. Alright, next we're going to go to the Cam tab. We're going to select this guy right here as well. And we're going to start a new job. When we set up the job, we need to tell it what coordinate system. The default for it was select that because it was active. If yours was not selected, you can come over here, click on this guy, and click the coordinate system so that that is your active coordinate system for your machining. In terms of stock, you want relative size, which is going to make it the same size as our model. Okay, we're going to go to a 3D milling operation, and we want to do a scallop toolpath. First thing we need to do is select a tool, so we're going to hit the library, and if you click on the sample library right here, and you change it to say diameter is, if you type in 0.5, you're going to come up with several options. What we're looking for is ball end mill, all right, and we'll pick the last one on the list for ball end mills. It really doesn't matter. And actually, let's see if we can edit that. So let us edit that. Shaft. All right, here we go. Cutter length is, actually that's going to work just fine because this is a smaller wing, so we'll leave it alone. Okay, we'll just hit the select, hit the select button and move forward. All right, so we've got our tool bit. You can see it in the preview here. We want to change some speeds and feeds. We're going to be cutting at some fast speeds, 15,000 RPM, so that's 15 with 3 zeros. The surface speed, the cutting feed rate is going to be 200 inches per minute. Okay, which is quite fast. Actually, I'm sorry, that was, 200 inches per minute should be good. We'll see. We may adjust that feed rate down the road, but we'll leave that for now. Hit the next one, which is the machining area, and we're going to hit selection. We want contact boundary point selected here, right here, and we're going to put 0 in for this guy. So tangent propagation, this is selected, tool centered on boundary. We're going to click here and here. Take a quick peek at this, make sure your settings match. All right. This tab will remain the same. This one we're going to change the step over to 0.1. Okay. And you should be able to hit the checks box. It should generate your toolpath. You should see a bunch of blue lines now. Those lines represent the actual path that the bit is going to take. So you're going to see it's got quite a ways to travel. And fun part's next, where we can go to stock simulation, take a look at what it's going to do. So you hit the play button. That was kind of fast, but you can see that that's what's going to happen to your wing. We're going to come back later and trim these pieces out. Those are going to be what we use to hold the foam in place as we're doing our cutting, and we're going to make some additional sanding and wrap it with some paper later on to give it a little bit more surface area. Okay, so now that we have the toolpath, the ShopBot does not run from the SolidWorks file that we created, so we need to export this toolpath. So before we do that, let's hit the save button so that our SolidWorks file is in good shape. And then after we've previewed, we'll just take a quick double check on that to make sure you have the right settings. Feed rate's 15,000. The spindle speed's 15,000. The feed rate's 200. You've got a step over of 0.1. All right, and if all of that is set, this should look like this. We did a preview of it. You can also do this simulate, which is another one that just shows the tool traveling along the blue lines. Okay, we're going to select that. We're going to hit the post-process button. And for now, we're just going to put it in our folder. So we need to select the correct post-processor. And there's a pull-down menu here. We're going to go to ShopBot Open SBP. Click on that. And under the program name, you're going to type in your last name. And we can put Airfoil in there. And I like to put the bit size as a reminder, so 0.5. I think this is all set to go. So we're going to hit, we need to put the output folder, the location. So I'm going to click on this and find my folder, which is in the tech drive in the student folders. You'll have to go hunting for yours. Airfoil, and hit open, hit post, and it's going to create an SBP file. We hit save. It's going to kick up the G code here. Whoop, did it on the other screen. This is what the machine sees, the ShopBot sees. These are all the values based on our coordinate system. It's going to move at a certain speed to a certain X, Y, and Z location. And obviously it's got quite a few movements to make in order to follow those blue lines. We can close that out, and that's all there is to creating the toolpath.